Hello students, in today's lecture we will be talking about combination of resistances. So, our current in a circuit depends upon two things, that is the potential difference of the circuit and the resistance of the circuit. We can combine the resistance into two ways. One is along the lengthwise, that is in series, or we can put the resistances parallel to one another. When the two resistances are connected end to end consecutively, they are said to be connected in series. But when these two resistances are connected between the same two points, they are said to be connected in parallel. Today, we will be moving ahead with the resistances in series or with the combination of resistance in series. So, according to the law of combination of resistance in series, the combined resistance, if I ask you, you need to take it out, the combined resistance of this circuit. How will you find it out? So, the combined resistance of any number of resistances. For example, in this circuit there are two resistances, there could be many, is equal to the sum of individual resistances. We just need to add up these individual resistances and we will get the resultant resistance of the circuit. Now I'll show you how can we derive the resultant resistance of two resistors in series. This is one of the most important topic of electricity in boards. So we'll be considering this diagram or this electric circuit which will help us to clear our concepts. We have applied a battery of voltage V. You can see that we have applied the battery of V volts. So the total difference, so the total potential difference would be, yes, it would be V equal to V1 plus V2. This would be our first equation. But students, we know that applying Ohm's law, if we will apply Ohm's law, what would be our V1? If I'll ask you, what will be the potential difference? What is V1, students? The reading of potential according to the resistance 1. So V1 would be I into R1. As we know, what is our Ohm's law? V equal to IR. So if we are taking that the first reading of the first resistance, the potential difference would be V1 equal to IR1. Why we have not taken I1? Because in this series circuit, the current flown would be I. It would be same for both the resistances. That is, the current for resistance R1 and for the resistance R2 would be same. So, from both the points, the current flown would be I. Similarly, this would be our equation 2. If I'll be applying for second one, that is the resistance R2, then V2 is equals to IR2. This will be our equation 3. So students, using these equation in the equation 1, what we will get, we know that V equal to IR, V1 equal to IR1 and V2 equal to IR2. So I have used the equation 2 and 3 in equation 1 and I got this resultant equation. Why I have written R to the subscript S? This shows the resultant resistance in series. I am taking out the combined resistance in series. So if we solve it further, what will happen? We'll take this I as common and what would be left behind? I R1 plus R2. Simply we will cut both the I and so the resultant resistance in series would be R1 plus R2. This is the required equation or derivation for the resultant resistance in series. Students, we now know that when there are many resistors in series, the formula would be R equal to Rs equal to R1 plus R2 plus R3 plus R4 and so on. Depending upon how many resistors are there in series, we will simply add up them all. So here is a simple numerical which we will be dealing, is that if four resistances each of 1 ohm are connected in series, what will be the resultant resistance? So how will we be calculating the resultant resistance? Yes, resultant resistance would be combination of all these resistances. And what is the value of each resistance? It is 1 ohm. So 1 plus 1 plus 1 and 1. So what is the answer which we are getting? We are getting the resultant resistance as 4 ohm. So students, our next sample problem is regarding this circuit. In this circuit, we are given two resistances of 20 ohm and 4 ohm, and a battery of 20 volts is connected to it. We just need to calculate the current through the circuit. So for calculating the current through the circuit, first step is to find out the resultant resistance. What would be the resultant resistance? Resultant resistance would be R1 plus R2, that is 20 plus 4, or that is 24 ohm. This is our R, and we very well know what is the V given to us, that is 20 volts. We need to calculate I. How will we calculating this I? By using the Ohm's law, which is V equal to IR, and I can even write it as I equal to V by R. Simple. V is 20 volts and R is 24 ohms. Solving it, we will be getting it as 5 to the 6, or that is 0.83 ampere.